All right, guys, so in this second video, what we are going to be taking a look at is how we can still add and subtract rational expressions when we don't have a common denominator. So if the rational expressions do not have a common denominator, then we're going to determine what's called the LCD and then add or subtract. Now, LCD stands for the least common denominator. And what this least common denominator is it is a combination of the factors from the different denominators, which is the smallest possible one that we could use. It'll probably be easiest to explain this by looking at a few examples using fractions in order to add or subtract. So let's do that now. So for this first problem, we're taking 1/3 plus 5/6, and we want to find the least common denominator. Now, remember, the least common denominator is the smallest number which both 3 and 6 would go evenly into. And we can probably all agree that that is a 6. Now, another way to think about this, though, would be to think about what the factors are for our denominators. For our first one, it's just the number 3. That's the only thing in our denominator. However, 6 could be factored to be 2 multiplied by 3. Notice that they both have a 3 in common. But the second fraction also has a 2. And in order to make our denominators the same, our first fraction would also need to have a 2. In other words, the smallest denominator we could possibly have, which would include everything we needed, would be equal to 2 multiplied by 3, which is 6. Now, keep in mind, if we're going to multiply our denominator by 2, we also have to multiply our numerator by 2. And while this might be a lot of work to think about for a fraction, it might just be easier to convert from 1/3 to 2/6. It'll be helpful to think in this way when we start to talk about our rational expressions. We can then go ahead and solve. 2 plus 5 is 7/6. And most of the time for this class, we will go ahead and leave our answers as the improper fractions. However, there are times where Big Ideas will want you to write that as a mixed number, in which case you would write this as 1 and 1/6, although, again, 7/6 would probably be the more common way to write the answer. So let's see how this would work for number 2. And again, we already know our least common denominator is most likely going to be 20, but let's find out how that's going to work. For our first denominator, we have the number 5, which can only be written as 1 times 5, so we'll just leave that as 5. But for 4, that could be broken down a little bit further. It could be broken down into 2 multiplied by 2. In other words, what we would need to do in order for our denominators to be the same is our first denominator would have to include both of those 2's, and our second denominator would have to include the 5. In other words, our least common denominator is 2 multiplied by 2 multiplied by 5, which is 20. Now again, just like before, if we're going to multiply our denominator by 2, we multiply our numerator by 2. And for our second fraction, if we multiply our denominator by 5, we also have to multiply our numerator by 5. What that's going to give us, our numerator for our first fraction is going to become 2 multiplied by itself 3 times, which is 8, over our common denominator now, which is going to be 20, minus, for our second fraction, 3 multiplied by 5, and our numerator is 15, over 20. And then subtract, we'll get a negative number this time, which is -7 over 20, and then we'd be done. All right, one last example of this. Let's take a look at number 3. Let's again take a look at our denominators first. So we've got 5 as our denominator for our first fraction. We've got 25, which can be written as 5 multiplied by 5 for our second fraction. And if we factor our third denominator, 10 is 2 multiplied by 5. So in order to make sure all the denominators look the same, our first fraction already has a 5, but it would need 2 5's because of our second fraction, and would also need a 2 because of our third fraction. For our second fraction, 25, we had 2 5's, we'd still need the 2. And for our third fraction, we already have a 2 and a 5, but we would need a third 5 in order to make sure that all of our denominators look the same. So our least common denominator would be 2 multiplied by 5 multiplied by 5, and that's going to equal 50. Now, we also have to do all of that also in our numerator. So for our first fraction, we have to multiply by 2 and 5. Second fraction, need to multiply by 2. And third fraction, need to multiply by 5. So that'll mean that our first fraction is now 20 over 50, plus our second fraction is 6 over 50, plus our third fraction is 5 over 50, and that's going to total to be 31 over 50. Now, in each of these cases, we didn't have any simplifying to do at the end. However, that is something that you should always be checking is, can I go ahead and continue simplifying? Let's look to see how this is going to work for rational expressions now. So for our first example, for example A, we've got x over x minus 2 minus 8 over x squared minus 4. Just like we did on the examples with numbers, we're going to look at the factors for our denominators. For our first denominator, x minus 2 is already factored. We can think of that as being x minus 2 in parentheses. But for our second denominator, x squared minus 4 is a difference of squares, and it would factor to be x plus 2 multiplied by x minus 2. Looking at our denominators, if we wanted for them to look the same, notice that they both already have x minus 2, but the second one has a factor of x plus 2, which is missing from our first fraction. In other words, we would need to multiply that by x plus 2. So now our least common denominator then would be x plus 2 and x minus 2. Now remember, if you multiply in the denominator by x plus 2, we also need to multiply in our numerator by x plus 2. For our second fraction, since it already had both x plus 2 and x minus 2, there's nothing that we would need to do there. So let's go ahead and simplify a little bit. Let's start by distributing our x plus 2 to x. So that would be x multiplied by x is x squared. 2 multiplied by x is 2x over our common denominator of x plus 2 and x minus 2. For our second fraction, we didn't need to change anything, so that's still just a minus 8 over x plus 2 and x minus 2. Now that we have a common denominator, notice that they're both x plus 2, x minus 2. We can now work this just like we did in the first part of this section, where we can go ahead and focus on our numerators. In this case, we're going to be subtracting 8. So we would have x squared plus 2x minus 8 in our numerator, and our denominator is that common denominator of x plus 2 and x minus 2. In order to simplify, we need to check to see if our numerator is factorable. Look to see if there are numbers which multiply to be 8 and also add to be 2. And in fact, there are. That would be x plus 4 and then x minus 2. Our denominator will stay the same, which is x plus 2 and x minus 2. There's now some factors that we can simplify. Notice that x minus 2 can be divided out, and that's going to leave us with our final answer, which is x plus 4 over x plus 2. Now, it would be a good idea at this point to go back to our least common denominator and go ahead and state any domain restrictions that we would have. I'll abbreviate that to be dr. For our first factor, x plus 2, we would say x can't equal negative 2. And for our second factor, x minus 2, we would say that x can't equal positive 2. Okay. So let's take a look at another example. So on example B, we've got 3 over x plus 2 plus 5 over x minus 4. So notice that our two expressions in our denominator are already factored. So you've already got x plus 2 factored and x minus 4 factored. However, they're not the same. And remember that your denominator has to be the same for both. So in other words, our first fraction would still need a factor of x minus 4. And our second fraction would still need a denominator with a factor of x plus 2. That way both had x minus 4 as a factor and both had x plus 2 as a factor. In fact, at that point, we now have our least common denominator, which is x minus 4 multiplied by x plus 2. Before we forget, why don't we go ahead and write our domain restriction. So for our first factor, we would say x cannot equal 4. And for our second, we would say x cannot equal -2. Now, going back to actually adding and subtracting, Remember that if you're multiplying by a factor in your denominator, you also need to go back and multiply by that same factor in your numerator. So for our first fraction, we'll go ahead and distribute now. X multiplied by 3 is 3x. Negative 4 multiplied by 3 is negative 12 over our common denominator, which is x minus 4 multiplied by x plus 2. For our second fraction, we've got 5 multiplied by x is 5x, and 5 multiplied by 2 is 10. Once again, those are over our common denominator, which is x minus 4 multiplied by x plus 2. It is addition, so we are now ready to combine some like terms. We'll take 3x plus 5x is 8x, and negative 12 plus 10 is negative 2. All of that over our common denominator, which remember is x minus 4 and x plus 2. Now we'll look to simplify, so we'll look to factor our numerator. 8x minus 2 has a greatest common factor of 2, which will leave us with 4x minus 1 inside the parentheses over our common denominator, which is x minus 4 multiplied by x plus 2. Once we've done that, notice that none of the factors are the same, so there is nothing that we can cancel out, in which case our final answer right here, and we're done. All right. We're looking at 3 more examples of this, and then that will be it for this section of the notes. So in example C, once again, our two denominators, while they might look similar, are in fact different factors. You've got x plus 1 and x minus 1. So what we need to go through and do is make sure that they both look the same. For our first fraction, we need to make sure and include that factor of x minus 1. For our second fraction, we need to make sure we include that factor of x plus 1. At which point we now have our common denominator, which is going to be x minus 1 and x plus 1. So for our domain restriction, we'll go ahead and do that now. We're going to have to say that x cannot equal positive 1 and that x cannot equal negative 1. All right, so now going through, we need to make sure that if we're multiplying by a factor in our denominator, that we're also multiplying by that factor in our numerator. And now we would be ready to distribute. Fortunately, for distributing in this case, we're distributing to a positive 1 in both cases. So for the first one, we just end up with x minus 1 over our common denominator. And for our numerator for our second fraction, we just end up with x plus 1 as our numerator, once again over our common denominator. So now, combining our like terms, it's just addition, so we can go straight to that. X plus x is 2x, and negative 1 plus 1 is 0. So then we have our final answer now, actually, which is 2x over x minus 1 and x plus 1. Notice that the numerator is already factored. It's just a linear term, and there's nothing then we can factor out since none of the factors are the same. All right. For our next example, example D in our notes, we've got 6x over 3x minus 1 minus 4x over 2x plus 5. Once again, our two factors are completely different, which means if we have 3x minus 1 in our first fraction, we also need that in the denominator of our second fraction. And if we have 2x plus 5 in the denominator for our second fraction, we are also going to need that in our denominator for our first fraction. Which then gives us our least common denominator, which is 2x plus 5 over 3x minus 1. So then to get our domain restriction, set each of those factors equal to 0, and we'll find out that x cannot equal 5 halves, and that x cannot equal 1/3. Going back to our expression now, remember we need to include those factors in both numerator and denominator, and then we should be ready to distribute. So looking at our first fraction, we've got 2x multiplied by 6x is 12x squared. 5 multiplied by 6x is 30x. All over our common denominator, which is 2x plus 5 and 3x minus 1. For our second fraction, 4x multiplied by 3x is 12x squared, and 4x multiplied by negative 1 is a minus 4x, all over our common denominator, which again is 2x plus 5 and 3x minus 1. Now it's important to remember what your operation is. In this case, we are subtracting, so we need to make sure that we leave this as subtraction. So let's go ahead and combine our numerators. So we're going to have 12x squared plus 30x minus, in parentheses, 12x squared minus 4x, all over our common denominator of 2x plus 5 and 3x minus 1. Distributing that minus sign now, our numerator is going to become 12x squared plus 30x minus 12x squared plus 4x, all over that least common denominator, which again is 2x plus 5 and 3x minus 1. At which point, to simplify, we do have 12x squared and a negative 12x squared, which add to be 0. We also have 30x plus 4x is 34x, over our common denominator of 2x plus 5 and 3x minus 1. At this point, we'll notice that our numerator is just a single term, so it's already factored, and none of our factors are the same, so we are done. We have one last example. Let's take a look at it now. So for example E, we've got x over x minus 3 minus 3 over x plus 4 plus 7 over x squared plus x minus 12. Let's start by factoring our denominator for our last fraction, since that's the only thing that would need to be factored. We're looking for numbers that multiply to be negative 12 and add to be positive 1, which, if you're not sure, a math teacher trick for you is oftentimes they will be the factors, which are the denominators for your other two fractions. Now that's not always the case, but if the problem is going to work out nicely and you're stuck trying to find those numbers, those are usually pretty good options to pick. And in fact, negative 3 and positive 4 are in fact the numbers which multiply to be negative 12 and also add to be positive 1. So looking at our factors, it looks like x minus 3 is in our first and our third fractions, so we're also going to need to multiply that in our second fraction. We also have x plus 4 in both our second and third fractions, so we will also need an x plus 4 in our first fraction as well. So it looks like our least common denominator is actually going to be just that, just those two factors, which again are x minus 3 and x plus 4. So for our domain restriction, we'll say that x cannot equal 3 and that x cannot equal negative 4. We'll then make sure that anywhere we multiplied by a factor in our denominator, we are also multiplying by that factor in our numerator as well. So now distributing for our first fraction, x multiplied by x is x squared, 4 multiplied by x is 4x, over our least common denominator of x plus 4 and x minus 3. For our second fraction, x multiplied by 3 is 3x, and negative 3 multiplied by 3 is a minus 9, again over our common denominator of x minus 3 and x plus 4. Now, although I wrote those in a different order for my first fraction as well as my second, they're the same factors, just in a different order, and that's okay. Remember that there is subtraction in between those two fractions. And then for our third fraction, since we didn't need to multiply it by any factors, we can just copy that down as 7 over x minus 3 and x plus 4. Before we combine like terms, let's go ahead and just write everything from our numerators together. So that would be x squared plus 4x minus, in parentheses, 3x minus 9 plus 7 after it. Notice that the 7 does not go in parentheses since it was not a part of our second fraction. Again, our common denominator is x minus 3 multiplied by x plus 4. We can now go ahead and distribute that minus sign to both of the terms inside the parentheses. So that'll mean our numerator is now x squared plus 4x minus 3x plus 9 plus 7, all over our common denominator, which is x minus 3 multiplied by x plus 4. Now we're ready to combine some like terms. X squared has nothing to combine with, so that'll stay as x squared. But then we have 4x minus 3x is a positive 1x, and 9 plus 7 is a positive 16, over our common denominator, which again is x minus 3, multiplied by x plus 4. Now before we're done, we need to check to see if we can simplify. In our numerator, we've got x squared plus x plus 16. So we would need to look for numbers which multiply to be 16 that also add to be positive 1. Only numbers that multiply to be 16 would be 1 and 16, 2 and 8, or 4 and 4. There's no way to get a 1 combining any of those of our numbers. So it turns out that our numerator is not factorable, at which point we are done. So that wraps up our section on adding and subtracting rationals. We now have covered all of the operations, so it will be time in our next section to look at how to solve rationals, and then from there we'll look at how to graph. Until then, have a great rest of your day.